It's very simple to operate the telescope. You can just click onto an object, and then the telescope tells whether it's above the horizon or below the horizon, and all you have to do is then say go. And a little light switches on in the dome so that you can see the telescope moving, and the dome rotates to the correct position and the telescope also.
And we also hear how it is doing there above.
Yes, yes. And we hear how the dome is rotating. So the dome is at the correct position, and now only the telescope moves to the position where the star is. And there's not so much to say. These are the right ascension and the declination where the telescope is pointing, the Julian date, and all these kinds of useful information. The elevation, the azimuth is also here. And actually these plots are very helpful because they say how long you can continue observing this object until it gets down to the horizon. Here's a little line when it's only 30 degrees above the horizon, so roughly at this point one should stop. Actually, the computer knows when it gets too close to the horizon and then stops, but the observer should also be informed how long it will take. Now, we have daytime now, but otherwise during the night, this is the TV camera, or the screen for the TV camera, which would show the stars we are looking at. There are two TV cameras. One is looking through this 30 centimeter finding telescope, and this is used for guiding or for acquisition to know if we are on the correct field and so on.
So we see the live picture right from the field of view.
Yes. And it has a field of view, this little telescope of 10 by 10 arc minutes, so much smaller than the main telescope. So it's mostly used for guiding and also to acquire objects for the spectroscopy. Then there's a second TV camera, and this looks onto the slit. So normally for spectroscopy we first look with the guide telescope, which is the correct star, and then we switch to and we put it into the middle of the field of view, and then we switch to the second TV camera, which looks onto the slit to move the correct star into the slit, and then we use the third computer over there just to take a spectrum. And most of the time we are really doing spectroscopy because we have two spectrographs, the high resolution one and the low resolution one, and imaging is only used maybe 30–40% of the time. It's mostly spectroscopy what we do. And actually we even have a second telescope here. It's only a 30 centimeter telescope, which is fully robotic, and that's the last computer over there. We just started at the beginning of the night, and it's just imaging and doing photometry of interesting objects.
Live field viewer.
Yes, and it's only 30 centimeter wide field little telescope, and it has a script, and it automatically observes the fields which we would like to have during the night. And in principle, if the weather is getting bad, the robotic telescope also closes itself. But during the night, here's always somebody, just in case that something really goes wrong, that can also do it manually.